Hello, Legacy students. So today we're going to look at polynomial divisions, synthetic version. So this is the second version of dividing polynomials. You're going to want your pen or pencil, notes, that booklet I gave you in class, and then also your thinking brain, and definitely be your listening ears. Go on to your next booklet. You're going to want to label it as synthetic division. Synthetic is another way to do long division. It's actually quicker. However, synthetic only works when you're dividing by a linear expression such as x plus 3 or x minus 1. So it's not as useful as long division. However, it goes 10 times faster than long division. So, synthetic takes a little bit of setup. Synthetic looks a little funky, I'm going to be honest. What you're first going to do is you're first going to figure out what would make your whatever you're dividing by equal to 0. AKA, I know that x would be 5, right? So 5 is a solution to the problem. So what I'm going to do is I'm going to set up an upside down box, upside down house if you want to consider it that, kind of like what you would have done for long division. And we're going to put this 5 on the outside of the box. Then what we're going to do on the inside here is we're going to fill out the coefficients of the problem we're dividing by. So aka the numbers in the front. So I notice x cubed's the beginning, so I'm going to put little notes on the top here that I'm going to have an x cubed column, an x squared column, an x column, and a no x column. So now let's fill out the numbers. So we got a 1 here, a -2 there, -8 is with the x column, and -35 is with this column. So now we've gotten the setup. Now what we need to do is use synthetic division. This is where it gets a little messy. So the first step to synthetic is you're going to drop the 1. Always got to just drop it. No matter what number that is, you're always just going to drop it down. Now, to get this next number right here, what you're going to do is you're going to take this number and you're going to multiply by the 5. So I'm going to go 1 times 5. I'm going to get a 5 right here. Big giant 5 right here. There we go. Then you're going to add these together. So -2 plus 5, that's 3. Same thing. Go up and multiply. So 3 times 5, that's 15. We're going to add here. So -8 plus 15, that's 7. Go up, multiply. That's 35. Add. That's 0. I like to put smiley faces on the zeros. Trust me, in a couple of days, you're going to definitely be putting smiley faces because you're going to be excited too. Now, this, you're like, oh, that's cool. What did that do for me? Well, what this did is it divided by an x. So ultimately, you started with an x cubed problem. Since I divided out a solution or divided out an x value, you actually have dropped the power down to an x squared. So this 1370 business, this is actually a new polynomial in secret code. But it's not an x cubed anymore because we took out an x. So technically you now have an x squared column, an x column, a no x column, and the remainder column. So my final answer for my division would be 1x squared plus 3x plus 7 for my answer. So if I divide this polynomial by x minus 5, I would get this for my answer as well. Same thing if you would long divide, you would get the same answer as well. Synthetic just allows you to break it down faster, and it's not as time consuming as well. Let's try another problem here. So I got x squared plus 3x plus 5. So first step we did is we want to figure out what would this solve for if I set it equal to 0, or what's the solution to this problem. So x would be -1, right? So we're going to put that outside the upside down house. And since x squared is the first term of our problem here, I'm going to put an x squared column. That's my first column. I'm going to have an x column, a no x column. So I'm going to put our numbers: 1x squared, 3 x's, and 5 no x's. Drop the 1. To get my next number here, I'm going to go 1 times -1, so -1. Add these two, 3 plus a -1, which is 2. Multiply, add, and I have finished. Now notice, guys, since we divided out an x, I'm no longer at x squared territory with this first part. I'm actually at the x territory. So I took away an x value because I divided out at one of the x values. So I have an x, a no x, and this is my remainder. So just like you just finished with long division, we're going to get 1x plus 2, and since we have this remainder, we're going to take care of it the same way you did with your long division problems. So I put my remainder over what you divided by right there. Alright, let's try another one here. So first thing, x would be 3 to make this 0, right? So I know 3 is going to be on the outside because my solution would be 3. My highest term is an x to the 4th, so I'm going to have an x to the 4th column, an x cubed column, x squared column, an x, and a no x column. So let's put our numbers that correspond to each of these particular powers. So I have 1x to the 4th. Oh no, I'm missing an x cubed in my problem, aren't I? So just like long division, you need that placeholder of a 0. They kind of go back and forth with one another. -10 is with x squared, 2 is for x, and 3 is no x. So same thing, drop the 1, multiply to give me 3, add here, multiply, add, multiply, add, multiply, add. Smiley face, got a 0. Yes. No remainder. A lot easier, right? So then what I got is an x cubed column here, x squared column, an x, and a no x column. So my final answer, 1x cubed plus 3x squared minus x minus 1 for my final answer after I divide. So this polynomial divided by x minus 3 will give me that for a particular answer. The last example here, I'm going to have you do it on your own. We'll check it over in class to make sure you know what you're doing, so that way you have an extra time to ask a couple of questions as well from the video. But until then, that's the end of this video. I'll see you later, Sabers.